Alors, bonjour à toutes et tous. Hello everyone. So the presentation will be recorded. I hope everyone is okay. La présentation va être enregistrée, donc j'espère que tout le monde est correct avec ça. Donc, je m'appelle Thierry Lefebvre, je suis coordonnateur du Centre de recherche sur les matériaux avancés de CERMA. I am Thierry Lefebvre, coordinator of Research Center on Advanced Materials, CERMA. And I will be, je vais animer l'activité avec Monsieur Pigeon que je vais vous présenter juste après. The activity will be in two parts. First, a presentation from Masoud, which will be introduced by Michel Pigeon. And after that, a discussion with all of you. Donc, nous aurons d'abord une présentation de Masoud et ensuite une discussion avec tous les participants donc, sur les cellules photovoltaïques. Je vais commencer par vous présenter donc Michel Pigeon, le professeur Michel Pigeon, qui va être l'animateur de l'activité. So let me introduce Michel Pigeon, the moderator of the activity. Michel Pigeon est professeur émérite de génie civil de l'Université Laval. He holds a master's degree from the Imperial College of Science and Technology in London, et un doctorat de l'Université Pierre et Marie Curie à Paris. He was director of the Inter-University Research Center on Concrete, holder on the Industrial Chair on Shot Concrete and Concrete Repairs. Il a été doyen de la faculté de sciences et génie et aussi recteur de l'Université Laval entre 2002 et 2007. Il a été aussi député de la circonscription de Charlesbourg à l'Assemblée nationale de 2008 à 2012. Michel Pigeon has received several awards and honors, including the Leonard C. Wason Awards for Material Research from the American Concrete Institute in 1991, and an honorary doctorate from the University of Liège in Belgium in 2006. Monsieur Pigeon prépare actuellement une thèse de doctorat à l'Université Laval intitulée « Réchauffement climatique, valeurs des jeunes et changements sociaux ». Donc, je lui laisse la parole pour vous présenter Masoud.
Alors, merci Thierry. Bonjour à tous et à toutes. Je suis très heureux d'être là et je suis surtout très heureux de vous présenter notre conférencier de cet après-midi. Notre conférencier est Masoud Shekargoftar. Il est chercheur postdoctoral ici à l'Université Laval, au département des mines, de la métallurgie et des matériaux. Il a étudié en République tchèque. He studied in the Czech Republic for his PhD. And while he was studying in the Czech Republic, he visited the Technical University of Denmark, où il a travaillé pendant 6 mois, et aussi à l'Université Friedrich Alexander d'Allemagne. Globalement, c'est une personne qui s'intéresse aux surfaces et aux interfaces, la science des surfaces et des interfaces, et son travail a beaucoup porté sur tous les éléments des cellules photovoltaïques. Et il va nous en parler, bien sûr. Et ce que j'aimerais dire, c'est que non seulement il va nous parler des cellules photovoltaïques, mais aussi il va nous expliquer à quel point, dans le monde dans lequel on vit, dans le monde qui a toutes sortes de difficultés, je dirais énergétiques, les problèmes de réchauffement climatique et tout ça, on a besoin d'énergie renouvelable. Et donc, Masoud va nous parler de l'importance des cellules photovoltaïques pour tout ce qui touche le développement durable. Il va nous expliquer là à quel point on peut à long terme compter sur cette énergie solaire. Et je me permets en 30 secondes de replacer ça dans le contexte des objectifs de développement durable des Nations Unies. Alors, I would like to say that the objectives of the United Nations concerning sustainability are very large, and they include not only scientific questions, but also social questions. It's important that we have a world where everyone can have access to a good job, access to energy, access to health. And so the objectives of that were defined at the turn of the century are important. We would like to have a planet that everyone can inhabit and have all that is needed. Alors, je laisse la parole à Masoud. Masoud, it's up to you now to talk to us about your work on photovoltaic cells and your opinion. How can they be used and how can they be useful to humanity and to the various societies throughout the world? Masoud?
Okay. Merci pour l'introduction. Il m'en fait plaisir d'être ici. And I'm switched to English. And it's my pleasure to be here. And thank you, Michel, for this introduction. And thank you, Thierry, for this opportunity to give me to be here. And I hope that it will be a useful presentation. So let's see about that. So now I would like to talk about the photovoltaics on the vision of how that technology can help to build a sustainable society. So we want to look at it on the prospect and limitation of this technology. So if you come to the Laval University and in front of the dormitory, you can see a small weather station which is working with the solar energy, and this is the one of the example of how solar energy could help us to produce energy which we need for functioning of any devices. So before going into details of the solar energy and how we can produce that and how we can use that, I would like to devote a few moments to talk about the sustainable development and what is the sustainable development. Based on the what United Nations provided, it means that development that meets the needs of the present without compromising the ability of future generation to meet their own needs. In a shorter word, it means that we shouldn't use the resources of the which is belongs to the next generation, and the Sustainable Development Goals are a collection of 17 goals that designated to be a blueprint to achieve a better and more sustainable future for all of us. And the Sustainable Development Goals that you can see here is set up in 2015 by United Nations General Assembly and are intended to be achieved by no later than 2030. So, and here we are looking into the how producing green energy and specifically producing energy from the solar can help us achieve those goals. So in 2018, global total energy consumption was above 40,000 megaton of oil equivalents. And in 2020, because of the pandemic and the lockdown, that's fell down 4%. But the estimation is that for 2013, that will increase up to 19%. So we need to be prepared by that time because this is also the time that we want to achieve the Sustainable Development Goals. So in general, why we need an alternative sources of energy, and this is the first and basic question that we should ask from us, because with this energy that we are producing, so we produce enough energy, but why we should look for new source of the energy? So the first thing, which is this year's become more and more important for us, is the global warming, because the fossil fuels and burning the fossil fuels produce huge amount of the carbon dioxide, which is one of the main reasons of climate change and global warming. And another thing is that we need a source of energy that can be affordable and for in everywhere, and which is easy to access. And another problem is that our currently resource of energy, like fossil fuels, are limited, and in many countries they are predicting to be finished in 50 or 60 years if we continue to use them as we are doing now. So this triangle, we call it a golden triangle. This is the criteria for any renewable energy. It should meet the criteria for the environment, which is very important. That should produce less pollution and less carbon dioxide, and also it should produce enough energy for our demands and global demands in 2030 or so forth. And also it should be cost effective, and it should be low cost energy that everybody from all the countries, from poor country to rich countries, can afford that. So here we can see the transition into renewable energy, and it is clearly seen that in the last decade, solar energy obviously getting more and more attention, and it getting more and more share part of the renewable energy around the world. And compared to other source of the energy, also wind energy is getting also more attention, and this both source of energy are leading the renewable energy research and also in the industry. So I would like to also share the basic of a photovoltaic cells and how it works. The photovoltaic cells working based on the photoelectric effects. What is the photoelectric effect? Photoelectric effect occurs when electrons are ejected from the surface of a solid materials like metals when exposed to sunlight. And we see that any material can react to this sunlight exposure is considered a photoemissive material, and the electrons, we call it a photoelectrons. So basically, in a photovoltaic cell, you just expose it to the air, and that's air, and that's light which is come from the sun. That's generating a pair of electron and hole, and that's subsequently generating a electric field and a current through the cell. So that's produced a electricity. So during the years, the field of the solar cell experiencing different generation. Most commonly used material for this is a crystalline silicon, and because the crystalline silicon is expensive, and also it is like have other issues that we will talk about in the next slide. So the research community looking for the other type of the solar cells which leading this community to make a cost-effective and more environmental friend technology. And in the last decades, since starting to producing the solar cell, we have experienced a number of the technology for developing the solar cell, which start with the crystalline silicon, then single junction, multi-junction, thin film solar cell, and very recently working with the solution processes like dye-synthesized solar cell, perovskite solar cell, which you can see a big competition in the searching for a high efficiency solar cell. And also we can see that the recent one, the solution processes solar cell, which we also talk about it in the next slides, are very competitive in terms of high efficiency solar cells. And with the huge investments that have made on the solar cell during the years, and as you can see here, in 2017 was above $150 billion was invested on a PV technology, and thanks to that, we can see that the price of the electricity and energy produced by photovoltaic is hugely decreased, and with this with the price rapidly decreasing for global average of electricity, the potential for solar energy to move from an expensive source of energy to more affordable source of energy is highly likely, and as we can see in this graph. And we want to see that who can utilize more and who can get more energy from the solars. So we, according to the study, that the most effective areas are near to equator of the Earth, because the intensity of the light is higher in those regions on Earth. And also, you can see here the warmer color indicate the higher solar energy in that area. And in Canada, as you can see, the southern provinces are has more capacity of the light intensity during the year, and has more potential of producing solar energy and utilizing the photovoltaic. And here, specifically in Quebec province, we can see that it is yellow, and it is in the range of 1100 to 1200, which is just promising, and it has a sufficient potential to use a photovoltaic technology. And how this photovoltaic can be used in our daily life? One of the most effective way to use the photovoltaic, not only for the producing energy, but also to save our water resources, is using floating photovoltaic farms, which is now using in many parts of the world. And the benefit of this technology is that you have a higher potential yield due to the waters that cool down the solar cells, and also it's very easy to install, and also it can prevent the water evaporation And another important thing is that this photovoltaic need to be cleaned frequently. So when they are floating on the water, you just have to like immerse them for a moment, and that can be cleaned very quickly and with a very low cost. And another part that photovoltaic can be used is that they can be integrated into the building. In the bottom photo, this is the center at the Switzerland Tech Convention. They used the organic photovoltaic to cover a whole building, and all this building is powered by the solar energy. And this example, and also other example that has a lot of benefits for this society. Like it can increase the energy efficiency. It can insulated the sound and the thermal. It has a very clean output without any pollution, and also zero carbon emission. And also PV can be used as a noise barrier along the highways in all the countries. This is also a very promising application. And also there are tens of the application that can be considered for potential application of the photovoltaic technology. And another important thing that we just need to consider, that how does the life look like when we are using a solar energy. So the first thing that you will find that you will not experience any more time out of use rate. The installation of this solar system can be considered as a investment. Also, the cost of this energy is fixed. You just pay for the system, and also there is no pollution and other benefits of using the solar cell in your life. And the environmental concerns. The important question is that, is PV technology really green? So the first answer that we should say that is that PV, like other technology, is not a perfect technology. So it has problems. So that we need to overcome all of them. For instance, energy consumptions for producing solar cell, which is it's one of the concerns. And another problem is the recycling of the solar cell. For instance, all the cells has a limitation age, for instance, 20 years, 25 years, and we need to figure it out what we will be doing after that time, and how we can dispose those panels. And another thing is that the carbon dioxide emission during the manufacturing, during the transportation, during the installation and maintenance of the solar cell. And also the silicon and other materials needed a mining activities, which is also have a negative effect on the environment. So now the question came to mind is that is there any alternative for those materials, especially silicons, or can we develop a technology that avoid those disadvantages? So there are many questions that can be asked, but the most important one can be asked as what are the alternative materials for the silicon? What are the barriers to developing such materials? Are those technologies environmental friendly, or can be reached efficiency comparable to regular photovoltaics? So as you remember at the first slides, we just show the different technologies that's now they developing to find a high efficiency solar cell. But one specific class of the technology that's started in the last decades is based on the solution process, and specifically the one the circle with a yellow inside, we call it perovskite solar cell. And as you can see, in 10 years, it reached a efficiency which is very comparable to the regular solar cell. And this one is one of the most promising technology that nowadays are developing and can be considered as a big rivals to the regular solar cell. And at this moment, there is a one company called Oxford PV is built based on the perovskite solar cell, and now it is already on a market. And this is one of the promising technology to replace the regular solar cell. So this solution process photovoltaic can be categorized into different materials, but the three remarkable class of this solution process photovoltaic are organic solar cell, dye-synthesized solar cell, and perovskite solar cells. And the advantage of those things can be they can be produced as a small dimension and a very low cost. They can be deposited on a flexible material and pretty much many type of the substrates, and they are more stable and durable than the regular photovoltaic. And for the deposition of this solar cell, there are a lot of ways to do the deposition. You can do it with the blade coating, thermal evaporation, slot dye, spray coating, inkjet printing, vapor depositions, chemical vapor deposition, and so forth. There are a lot of technology that can be used to develop this photovoltaics. And one of the things that can be considered also to improve the efficiency and also involve different type of the materials, which can also reduce the costs and also overcome the environmental concern, is that the using we call it surface and interface engineering. And this is my contribution to this field, that I use the different type of the surface and interface engineering, such as chemical treatment of the materials. We use the graphene, we use the carbon nanotubes, and other type of the chemical treatment. We use the thermal treatment of the coatings, and we use the coating of the substrate, and we also used one of the promising way of the surface processing. We call it plasma, and in some freelancer books, they call it the fourth state of the matter, which can be used for the processing of the materials. So based on what we have discussed and what we have presented, now there are the questions that we should answer them. So that one of them is that I'd like to know what's your point of view about the PV, and what will be the future of the photovoltaic. And another thing which is very important is that is solar energy sufficient to make society sustainable, and which part concerns you most in terms of the environmental effect, in terms of the cost, and other issues about that. And I just wanted to thank you all for your kind attention. And I want to thanks to my colleagues from my previous institutes, which I was there, and thank for the Brno PhD Talent for supporting my PhD during my study at Czech Republic, and also people at the Denmark Technical University and people at Masoud University. I would like to thanks to all of them, and also thanks for the audience for your kind attention, and thanks for the people and Thierry and Michel here. Thank you very much.
Alors, Masoud, ou devrais-je dire docteur Shekargoftar, merci beaucoup. Thank you very much. Comme toute bonne recherche, ce que je comprends, c'est que ça soulève beaucoup de questions. C'est de la vraie recherche et vous avez à la fin posé des questions, et ce sont des questions que vous imaginez que les personnes qui nous écoutent se posent. Alors, moi, j'aimerais ouvrir la discussion et faire en sorte qu'on puisse avoir des questions de l'auditoire et que vous, Masoud, vous puissiez donner votre point de vue sur tout ce qui a été soulevé et en particulier, moi, je dirais, le futur. Est-ce que notre futur sur la planète dépend des cellules photovoltaïques et du développement? Est-ce que c'est une contribution? Est-ce que c'est une solution miracle ou optimale? Hein? So, we will ask the persons in the audience, in the virtual audience, to ask questions, and it should be interesting to see what they think and what you think of what they think.
Yes.
Alors, les questions sont là. Je pense que c'est à vous maintenant, là, les auditeurs ou les auditrices, les personnes dans l'assistance. On attend vos questions et je crois que Thierry va vous expliquer un peu comment poser vos questions.
Oui, en fait, le plus pratique, ça va être de poser vos questions dans le chat. So the easiest way to ask questions is using the chat because we have a problem with to hear you. On a de la difficulté ici dans la salle à vous entendre, fait que ça va être plus simple si vous posez vos questions par écrit. Il y a déjà une question.
Oui.
There is a question.
You can see?
Yes. There is a question. Thank you, Josein, for this nice question. And my apology if I don't spell your name correctly. The question is that the best perovskite solar cell contains toxic lead, which poses a hazard to the environment. In your opinion, do you think that the perovskite solar cells are really an improvement compared to silicon solar cells? Yeah, that's a really, really good question. Perovskite materials are a general terms. Yeah, the one that contain lead, such as methyl ammonium lead iodide or methyl ammonium lead chloride, or in general methyl ammonium halide. Yeah, they contain lead, and the one of the things that we need to replace is replacing the lead, which is now many groups using different type of the perovskites, such as methyl ammonium with tin halide, and also there are also other type of the perovskite material that they are using, that they want to avoid using any lead in the perovskite. Yeah, this is the very, very important point, and thank you for the question.
Merci. D'autres questions qui vont apparaître? Est-ce que d'autres questions apparaissent pour l'instant? Thierry, peut-être que vous avez des questions?
Moi,
j'en aurais aussi, mais allez-y.
J'en aurais une. Je l'ai écrite, je vais la dire en anglais. a recent report from Carbon Brief, a British organization, announced that we only have 10 years of emission if you want to respect the target of 1.5 degrees Celsius. And you also have mentioned the target of 2030 for SDG. So I wonder, what do you think, or what can you tell us about the spread of solar cell? Is it rapid enough? And for example, you have shown large investment in this type of energy. Do you think it's enough to reach these targets?
No, it's absolutely not enough, because the damage that the climate change made, it was much more faster than the investment and the activities that we have done in the last few years. So yeah, it is absolutely not enough, but I think at least we started to invest more, and we started to realize that's how we can face this problem. Yeah, but I think the speed that we are going to the clean energy is absolutely not enough.
Okay, thank you.
Il y a d'autres questions peut-être déjà?
Oui, il y en a une qui est arrivée. Quelqu'un demande si les cellules solaires organiques sont recyclables. Do you know if organic solar cells are recyclable?
Yeah, the organic solar cells, yeah, because they're mainly using polymers and organic materials. Yeah, they can be recyclable as well. Yes, but the problem with the organic solar cells is the efficiency that we can achieve with this solar cell, and that's why perovskites can like go for the higher efficiency than the organic, and now it is gaining more attention compared to the organic solar cell.
D'autres questions?
Oui, une autre question de Laetitia Marin. Do the flexible solar panels last as long as traditional style?
Yeah, this is also very, very important, the durability of the solar cell. It can last long more than the regular solar cell, but the problem with this flexible solar cell is that we need to produce them in a larger area, and with the larger area, the efficiency are going down, and this is also a problem. But with the durability, they can last long as a regular solar cell.
Alors, est-ce qu'il y a une suite, Thierry? Est-ce qu'on voit...
Oui,
moi, mes yeux ne sont plus ce qu'ils étaient. Et sur l'écran ici, est-ce qu'il apparaît d'autres questions?
Une question de Quentin. Organic solar cells have tendency to deteriorate due to the heat. How could we increase that in order to use them in the most warm part of the world?
Yes. This is also very important. This is at the higher temperature, they are degraded. So one of the topic that could be making a materials engineering to have a higher temperature resistant, and in terms of the degradation and deterioration of that. So we need to first figure out those problems, and this is the main barrier for the organic solar cell. And as I say that, in terms of efficiency, organic solar cell are behind the new topic, which is a perovskite solar cell.
Mais si je peux, if you allow, Masoud, there are questions concerning the various possibilities of various materials, difficulties, possible solutions, and what is your point of view? What is your point of view concerning the energy transition? You said we were not going fast enough. if we invest sufficiently in research with all the know-how that you have concerning solar energy, is it possible to imagine that in 10 years' time, perhaps we would have, the technology would have advanced so much that we could say we have succeeded in the energy transition? Is it possible to imagine that with sufficient research, we could go to the development? You were showing a graph at some point concerning the use of various types of energy. We want solar cells to occupy 50%, 60%. Is that?
Yes. Yes.
And when can we have that if we put sufficient effort?
Yes, here. Yes, as you can see here, in I would say 2 decades, since 2010 to 2020, the share of the solar energy, it's obviously and remarkably increased. So that has not came suddenly. It's because we have invested. I will show the graph for that. That's because we have invested billions of dollars on this technology. And for the question that's is it possible to reach in 10 years? I think it is possible, because if you look at the perovskite solar cell, if they started around 2010, 2011, the circle with a yellow, this one, sorry, here, it started from 2011, and in 10 years, it reached the efficiency which is comparable with this regular solar cell, which that one reached more than 4 or 5 decades. So that is also very important to invest on a new technologies, in terms of material processing, in terms of the research and development of those technologies to produce the.
But what would be the environmental gains from using perovskite versus silicon?
Yes, as one of the audience pointed out, one of the problem with the perovskite is that in some of the composition they use lead, which is also toxic for the environment. So we see that in terms of efficiency, we are quite comparable with the regular solar cell. But in terms of the toxicity and the environmental concern, we need to invest more, and we need to work more on that. So it is as I pointed out here, there is this one, a golden triangle, we call it, and this is very important. When you find a source of new energy, you need to consider this 3 very important parameters. How does it affect the environment? How much you get energy, and what is the cost of that? So I think this is also very, very important to consider if you want to go for the renewable energy. But unhappily, now climate change is not in a, I would say, very, very good condition. So we need to act fast. At least this technology are not producing carbon like fossil fuels. So this is also, you need to consider this point. And there is no perfect technology. Each technology has a disadvantage, and we also need to consider those problems.
Thierry, est-ce qu'il y a d'autres questions?
Pas d'autres questions, mais j'aimerais... I would like to add something about what you said, Masoud. You mentioned very fast technological progress, but the deadline is very close to us. So yes. I just wonder, do you think that reduction of energy consumption should be the priority before research development, which, yes, progress are fast, but the spread of this technology is not so fast, and we have very strong deadlines.
Yes, and yeah, I think the best way is that to move all of them together if possible. You cannot just say, okay, I just produce the renewable energy, so I will forget the rest. No, you need to optimize use of energy. You need to insulate, for instance, the buildings to don't waste more energy. You need to optimize all the devices. So this is also one of the way how to reduce carbon emission. You need to invest on the wind energy, on the solar energy, on the other type of the green energy. And this is we are. I think if we invest in all this renewable sources, and if we taking into account how to optimize using the energy, so that's we may I would say not reach the 100% of those goals, but at least if we reach to 80%, 70%, is still acceptable. But unfortunately, the condition of the climate is not in a very stable moment.
So, maybe
oui, allez-y, Thierry.
Maybe I can go on.
J'aurais une question.
I have a question for you, Masoud, but also for you, Michel, and for all of you that you are looking at us, because we have some developing countries that need energy for their development. And we here in rich country, we have to decrease strongly our energy consumption. So I just wonder, how can we manage these two difficult challenges? On one hand, we have to reduce strongly our own energy consumption, and on the other hand, we have to help developing countries to reach energy standards for their own development. So I have no answer for that, but I just curious to hear you about this question.
Moi, ce que je comprends des propos de Masoud, et je pense que il n'y a pas de solution miracle, et il faut absolument aller dans toutes les directions. Donc, autant diminuer ici au maximum notre dépense énergétique, faire la transition, travailler sur l'isolation des bâtiments, travailler bien sûr aussi sur le transport en commun, les besoins en transport, et aussi se pencher sur les questions, comme vous mentionnez, des pays en développement qui ont besoin d'énergie. Et moi, ce que je vois de ce que Masoud nous dit, c'est que les cellules photovoltaïques, quand on regarde la carte du soleil, les pays en développement ont quand même une ressource que nous, on a moins ici, et c'est le soleil. C'est pourquoi la recherche m'apparaît très intéressante. Mais la question que moi, j'aimerais poser à ceux et celles qui nous écoutent, c'est, voyant ça, est-ce qu'en écoutant la présentation, ce qu'on connaît des cellules photovoltaïques et des besoins en transition énergétique, êtes-vous optimiste? Êtes-vous pessimiste? J'aimerais ça que quelques personnes nous répondent et nous disent comment ils voient l'avenir dans les 10 ou 15 ans concernant la recherche et les besoins, donc, de réfléchir à cette question de la transition énergétique.
Pendant que les gens rédigent leurs réponses, je voudrais juste ajouter que one of the advantages of solar cells is that they are very flexible because they can be implemented locally and on a small scale. So this is very, and they are cheap. You've shown that they are cheap. So this is very important for developing countries, these advantages. So on va reprendre la question de Monsieur Pigeon. Êtes-vous plutôt optimiste ou pessimiste sur la transition?
Moi, je veux pas répondre à la place des gens. Je vais les laisser répondre. Mais en attendant que les réponses apparaissent à l'écran sur la vision que vous avez, vous qui nous écoutez, de la transition énergétique, peut-être qu'on pourrait s'adresser à notre conférencier qui pense à ces questions-là depuis très longtemps. Masoud, are you optimist when you think of all the possibilities and all the difficulties and the immense complexity of the problem which touches both social aspects, economic aspects, and so on? What is your point of view for the future? I don't know if you have children, or grandchildren eventually, but do you think they will still have a livable planet?
Yeah, I am optimistic about that. I will explain why. Because if we go back to the 20 years ago or 30 years ago, I was a kid by that time, but when we saw the cars and the vehicle and all the energy consuming devices, by that time nobody cares about how much this vehicle will consume all those stuff. But at this moment, it's become the dialogue of the even ordinary people that they say, okay, I want to buy a car with less consumption. So, and if we make a good introduction about the solar cell, that say, okay, you just install the cell, you pay for the cell, and then for 20 years, you don't need to pay anything for your energy of your apartment, which I think this is one of the very, very good points that we need to make a better introduction to the people, to make them concerned that each one can participate in the saving the planet, and also in terms of the developing country, the same. We need to support, and we need to make a better understanding of how deep is the problem and how each one of us can help to prevent this climate change don't go worse. I think this is the one point to investment on the research and development, yes. And another point, we need to make a better introduction to the world. Doesn't matter it's developing or developed country. We need to make this as well. This is my opinion.
Nous allons prendre la dernière question.
Oui, allons-y.
De Josiane, qui dit I will answer with a question. Donc, à votre question sur l'optimisme ou pas. If the world would decide to completely abandon fossil fuel tomorrow, do you think we are ready to manage this energy transition with the clean tech we have available right now? Or do you think that it would actually be more damaging to the environment to implement this clean tech at large scale? Très excellente question à mon avis.
Masoud?
Yes, this is a smart question.
Smart question.
Yeah, from the climate change point of view, if you look at it, what caused this climate change? One of the big causes is producing pollution and carbon dioxide and burning fossil fuels. Okay, so this one absolutely is the main reason for this climate change. Okay, so if this colleagues say that suddenly we just abandoned fossil fuels, okay, it is not bad. But are we prepared for that moment to abandon the fossil fuels? I don't think so. I don't think so. We are prepared. in terms of the global economy, in terms of the industry, in terms of even the daily life of the energy consumption, we are not prepared to produce enough energy from the clean resources. So that's why we need a transition period. So
how long will how long should the transition period be?
It should be less than this 9 years left to 2030.
Okay.
It should be that one, but it is very, very difficult because this summer I was following the news about the climate change. So one day you just look at the news, same day in British Columbia, same day in US, same day in Pakistan, same day in Russia, we have a firing of the forest. So the same day. So that's show how deep this crisis is. So because it is unbelievable, same day in all around the world, in Australia, we have like the fire. So this is the big alarm. So we need to act fast. Whatever is the price for that, we need to pay that. And it's not for instance, we are sitting in Canada. We say, no, we don't pay it. We just, take care of ourselves. No, it is a collective behavior of all the human. It doesn't matter wherever you are. So let's show that, in North America, South America, Asia, Middle East, I don't know, Europe, all the part you saw this effect. So you need to act now. It's already late, I think, but so I think this is my opinion about that.
Nous avons un dernier commentaire.
Un dernier commentaire.
Je sais pas si on le commentera, mais c'est Laetitia qui se considère optimiste. Elle dit, however, I hope that the attitude of our government could go to the same direction and point out for the investment of green energies. The scientific part, you guys, are doing great. But what is missing to implement it in large scale in our society? Je ne sais pas si c'est une question ou un commentaire la dernière. Non? What is missing to implement it in large scale in our society? Je pense que c'est une question.
Yeah, this is also. So you wanted to?
No, go ahead.
Yeah, this is also a big issue because if you look at how many research groups now working on the solar cell, I would say maybe 1,000 groups around the world. And another question is, how many companies do you know that are producing, especially this new solar cell like perovskite? Probably 10 or less. So it is not enough. For instance, for the perovskite solar cell, I know only one company that's in the UK, Oxford PV, and they have one sector in Berlin, and that's it. So it is not enough. We have a lot of publication. I didn't wrote it here, but for instance, in the perovskite, 2 years ago, it was above thousands of publication on one topic. But how many real production in the real world? Very little. So that is also the big issue that we need to consider. Of course, it's very important, research and development, but what matters most is that how you put that research into the real life. I think this is also very important.
Le mot de la fin, est-ce que... écoutez, on a eu... D'abord, je vais remercier Masoud, le docteur Shekargoftar. Il ne faut pas que je me trompe. Alors, thank you very much. Merci beaucoup. Merci non seulement de nous avoir donné de l'information, mais aussi de nous avoir aidé à réfléchir. Et je pense que ce genre de discussion-là est fondamental parce que ça permet à toutes les personnes je dirais, de réfléchir à ce qu'ils et elles peuvent faire. Et je pense à la dernière remarque qu'on vient de voir à l'écran, là. Cette remarque-là est importante. La recherche, c'est fantastique. Great guy, hein? La recherche, on y va, c'est bon. Mais on a besoin collectivement d'agir. Et pour ça, je pense qu'il faut tous et toutes qu'on soit conscients et qu'on fasse pression sur nos gouvernements pour que les décisions aillent dans le bon sens. Et on se doit aussi, en fait, j'avais une idée en arrière de la tête quand j'ai dit « êtes-vous optimiste ou pessimiste ?» J'ai l'impression que si, on n'a pas le choix, si on est pessimiste, on n'ira nulle part, on ne fera pas les efforts. On doit être optimiste. On doit se dire « oui, on peut gagner ce combat. Oui, on peut faire pression sur les gouvernements. Oui, on peut sensibiliser notre entourage. Oui, on peut changer l'éducation et faire en sorte que les gens finissent par avoir les bons comportements. Je pense qu'on n'a pas le choix pour l'avenir, pour les générations futures. On n'a pas le choix que de rester optimiste. Je dirais un optimisme prudent, n'est-ce pas? Et de continuer, bien sûr, puisqu'on parle de recherche aujourd'hui, de continuer en recherche. Alors, merci encore une fois. Merci. Masoud, d'avoir répondu à toutes les questions qui ont été posées. Thierry, merci d'avoir organisé cette présentation. Et comme je le disais, on a besoin de ce genre de discussion le plus possible. Il faut en parler beaucoup. Merci à toutes les personnes qui ont assisté, qui ont écouté et qui ont probablement encore plus de questions que de réponses, je le conçois, mais qui ont aussi eu de l'information et qui vont pouvoir être dans leur milieu respectif des diffuseurs. Alors, au plaisir de vous revoir virtuellement dans un autre forum.
Merci à vous d'avoir animé les débats et d'avoir pris le temps de participer à cette activité.
C'est avec plaisir que je l'ai fait.
Donc, bonne fin de journée.
Bonne journée.